You're looking at the numbers first. You got 24, 12, and 60. Now, you're trying to find the greatest common factor between those numbers, and then we'll worry about the letters in a minute. But one way to start would be try the smallest number. See if the smallest number goes into all of them evenly. Because no, it goes into itself once. Does it go into 24? Yes. Does it go into 12? 60? Yes. So we can use 12 as our greatest common factor of the numbers. Because 12 goes into all of them evenly. Goes into 24 and 60. Now, let's look at the letters. Let's look at A's. They all have an A. What's the smallest? A to the third. Okay, because I can't take 3 A's out of that one. I can take 3 A's out of that one, but I can't take 10 A's out of that one. The most I can take out of any of the 3 is 3. A to the third. Let's go to the B's. Do they all have a B? No, this one doesn't have a B. So I can't put B as a common factor. This is not common. They don't all have it. They all have a C, but the most I can take out of all of them is 1. I can't take 3 out of this one because, if I wanted everybody to give me the same amount of money, but you only had 1 penny, then you can't give me any more than 1 penny. And if you all have to give me the same amount of money, then you all have to give me 1 penny. So it's all based on whoever has the least. Right? So A to the third C. That's your greatest common factor of these 3 terms. If 19 doesn't go into 152 and 19 is prime, then 1 is going to be our greatest common factor of our numbers. The only number that will go into 19 and 152 evenly is 1. So I can put a 1, or I can just don't put a number at all. Just go to the letters. We got x to the third and x to the 8th. Go by the smallest one. So x to the third is my greatest common factor. 1x to the third, or x to the third is my greatest common factor of those 2. That's the answer. What I get for not doing the calculations myself and trusting some people to use a simple calculator. 19 does go into 152 evenly. 19 goes into 152 exactly 8 times. And so 8 is the common, so 19 is the common factor. Okay? 19 is the common factor between 19 and 152. 19 goes into itself once, and 19 goes into 152 8 times. Then the x to the third. So that should be correct. Okay, number 4. X squared minus 5x minus 66. We're supposed to factor each polynomial if possible. Since there's a 1, or since there's no number, it's an implied 1 in front of your squared term, you don't have to do factoring by grouping. You can still do your T-chart, and 1 times negative 66 goes there, and negative 5 goes there. This is what you're trying to multiply to get to. This is what you're trying to add to get to. So negative 166. What are my factors of negative 66? Negative 11 and 6. 6 and 11. No. 3 and 22, right? 3 and 22, one of them being negative. The opposite. 33 and 2. Okay, but we're getting off track because they're going to have opposite signs, and we need to, when they add together, give me negative 5.
Yes.
Right, and the better you get with this, the quicker you're going to come up with the right combination, and you don't have to do every single one. So this one adds up to, negative 11 plus 6 is negative 5. So these are the 2 I want, the negative 11 and positive 6. So I can go straight. I don't have to break up the 5x into negative 11x plus 6x when it's a 1 in front of the x squared. I can go straight to my binomial multiplication. So x minus 11 and x plus 6. I'm going to check. It's always a good habit to go through and check. X times x is x squared. X times 6 is 6x. Negative 11 times x, negative 11x. Negative 11 times 6 is a negative 66. And those two become my negative 5x. Okay, and that's right, and that's right. Okay, so I'm confident that this is the right factorization because it gets back to what I started with. On number 5, the number in front of your squared term is not a 1. And so you can do this two ways. You can take and do 4 times negative 24 and put that here, negative 124. And then you can try to find out what's going to add to positive 8. Or you might notice that all the coefficients are all divisible by 4. And so you could take the 4 out, factor the 4 out, and you'd be left with x squared plus 2x minus 31. Which is now, if you factor this inside, this is factored, but it's not totally factored. I factored out a 4, but this needs to be factored. What's inside parentheses needs to be factored also. So, but I have a trinomial that has a 1 as the coefficient. So now I don't have to do the factoring by grouping, but you could if you wanted to start with the very beginning. So I'm just trying to figure out what's going to multiply together to give me negative 31 and add together to give me 2. Wow, 31 is prime. So really I can't break it up anyway. I can't find factors of negative 31 except for 31 and negative 1 and negative 31 and 1. And neither one of these are going to add up together to give me a positive 2. So if that's the case, then I stop at that point, and that is my answer. It is not prime because they all have a 4. I could factor out a 4. This piece is prime. That part is prime. But the 4 has this is not prime because it has a common, all those terms have a common factor of 4. Okay? So if you put prime, I gave you some credit. I didn't count off as much because part of it is prime. Okay? And if you try to factor that using the grouping method and you didn't see that all of them had a 4, you would think that that was prime, but it's not. Okay, number 6. You could factor this by grouping right away and say, okay, my first two terms both have an x in common, so I could take an x out and be left with x plus 6. My second two both have a 6 in common, and if I take a negative 6 out, I'm also left with x plus 6. You could do that way and get x plus 6 is their common factor, and then you have an x and a minus 6. Or you could notice, and you need to be able to notice things in math, that x squared plus 6x minus 6x is going to become 0 in the middle. Those are going to cancel each other out. And you'd be left with x squared minus 36. You could. This is two different ways. You could do that and get this answer. You could do factoring by grouping and not cancel and get that answer. Or, that's right, you would get the same thing. You would notice that both of these are perfect squares. Square root of the x squared goes here. Square root of the 36 goes here. One's positive, one's negative. Either way, take the shortcut using differences of squares or factor it by grouping. I don't care which one you do. This is one answer I want. Okay.
So if there's no coefficient on the x, you don't put an x on the outside of it.
All right, number 7. Different approaches you could take here. You could look at and see that both of those have a 2 in common and take out the 2. The best way, let's just look at the best way. The best thing to do here is take out the greatest common factor, which would be what? 2x squared. Very good. And so what would you need here? If you need 2x squared times what is going to give you 2x to the 4th? Another x squared. Okay? Because you have to make sure that when you go backwards, if you went backwards, it would give you the same thing as what you started with. And so what would I need to put here to give me a negative 18x squared? That's 9. 2x squared times negative 9 will give you the negative 18x squared. Are we done? Oh, wait, there's more. This is a difference of 2 perfect squares. So not only do you have your 2x squared, but this also needs to break up into the square root of the first one, the square root of the second one. One's positive, one's negative. Then you're done.
I did all that when I put the square.
So, looking at x to the 4th minus x squared, I want to factor that completely. What do they have in common? Let's try to always take out the greatest common factor first. And what will be left? And then check and see what you have left after you factored it out. Can you factor that some more? Can you factor x squared minus 1 more?
No. Yes. Oh, yeah.
It's a different, one is a perfect square. Magical perfect square. Because its square root is itself.
Oh, yeah. Okay.
You have x squared, and then x squared minus 1 breaks up into x plus 1 and x minus 1. So this is the one we talked about. That this is that, right? This is the correct answer, and the correct answer is not there. If you factored out the x squared first, you would get that. If you took it and did it as a difference of 2 squares right away, you would get square root of x to the 4th is x squared, square root of x squared is x and x. One's positive, one's negative. If you did it that approach, you'd get a, neither one of which is factored completely. We'll move on. Number 9, factor completely. 16x to the 3rd minus 81x. Let's take out the greatest common factor first, which would be what? Does 81 and 16 have anything in common? 8, 2, 4. Well, if it didn't have 2, it's not going to have 4. Or 8. So, let's go with the x's. We're just going to take x out. And we're left with 16x squared minus 81. Now what can we do with that? Are both of the terms inside that perfect squares? Shake your head up and down. Yes. So you have your x, which stays out front, but then the 16x squared minus 81. The square root of 16x squared is 4x. Square root of 81 is 9. One's positive, one's negative. Now, can you factor either one of those? Almost. You can almost factor that. That's almost a difference of 2 squares. The 4 is a perfect square, the 9 is a perfect square, but I only have x to the 1st. I can't do x to the, I can't do anything to get x to the 1st. Can't take square root of that. So it's not in the real numbers. So we'll stop there. And the answer choice we pick, C for Charlie. Number 10. Let's skip 10. I don't feel like wasting time on the video. All right, number 11, solve each equation by factoring. The whole reason we're learning to factor is so we can solve. Okay, so now that we've learned to factor, we need to look and make sure, okay, all three of those things, this has already been totally factored. Okay, and it's set equal to 0, which means the only way I can get 0 if I'm multiplying numbers together is for one of them to be 0. Well, 6 can't be 0. Never. Okay? D minus 4 could end up being 0.
Sure.
And 5D plus 8 could be 0. So what value of D would make this part equal to 0? Add 4, D could be 4. And if D is 4, I get 4 minus 4 makes 0, and everything goes 0. Or, subtract 8, divide by 5. 5D is negative 8, and divide by 5, D could be a negative 8/5. If D is a negative 8/5, then that becomes negative 8 plus 8, which is 0, which makes the whole thing 0. So these are the two possible solutions for D, the two possible values for D that could make this whole equation turn into 0. Okay, and where's the answer choice? D.
Oh, I'm kidding.
Not kidding.
You chose C, didn't you? Yes.
Number 12. If we learn from what we did in number 11, we need to set this equal to 0. So to move the 2 over and have nothing left on the right side, it would look like this. 2a squared minus 3a minus 2 equals 0. Factor that. Okay. We need two things that multiply together to give us negative 4 and add together to give us negative 3. We've done this enough. We know that's going to be negative 4 times 1, negative 4 plus 1. So that means that this middle term will break up into minus 4a plus a minus 2 equals 0. We're going to have to do this by a grouping because we have a 2 as our coefficient on the squared term. So then if I factor out a, well, y'all like reversing the middle terms? Does this mess you up? We'll reverse the middle terms so that there actually is something in common. Plus a minus 4a minus 2. So the 2a squared has an a in common, 2a plus 1. And if I take out a negative 2 here, I also get 2a plus 1. I need these to be the same. So sometimes you have to take out a negative, sometimes you take out a positive. But you need them to have that common factor in parentheses. You need whatever's in parentheses to be the same. So that they have that common factor, 2a plus 1. And what I took them off of is an a minus 2. That's equal to 0. So that means either 2a plus 1 is 0 or a minus 2 is 0. So if this part was 0, subtract 1, 2a is negative 1, divide by 2, a is negative a half, or add 2, a is 2. Those two values of a, when you trace all the way back to what we started with, those two values of a will give you 2. Yeah, they gave you 0 here. Those are two values of a that made 0, but ultimately, the problem that we started with was what two values of a, what values of a could you put in to get 2? And these are the two values of a that you could put in to get 2. Okay? We manipulated this equation so that we could find those values a little bit easier, but this is what it was all about. It was right here, values of a that will be equal to 2. You can put them in and test. Because you need to put them in and test it up here, because you might have done something wrong in the process of factoring. And if you did something wrong in the process of factoring, you've got two answers that may not be correct. You need to check them back in the original, okay? And if they work there, then you know that you're right. Should have been A. The difference between this problem and the problem before is that there's no x to the first term. There's an x squared, and then there's the constant. But there's no x to the first term. Okay? So the only time we really see that so far is when we have differences of squares. So that could be what we're coming up against right here. Let's factor that. What do they have in common? 7. We'll take a 7 out, I'm left with x squared minus 4 equals 0. And that's one of those things I thought it might be. It's one of those differences of squares. So 7, and then x squared minus 4 factors into x plus 4, x minus 4, and it's still equal to 0. So what values of x would cause me to get 0? If you're not quite going, if you can't quite get through that process in your head yet, okay, x plus 4 is equal to 0, or x minus 4 is equal to 0. One of those are the only two possible ways to get 0. 7 can't be 0. Oh, I messed up. Look what I did, look what I did. That was supposed to be x plus 2, x minus 2. Y'all didn't catch me? X minus 2, x plus 2. No one caught me. Everybody's still on spring break. Should have been B. After I've set it equal to 0, I want to try to factor anything out. If they have a common factor, I want to take that out. What do they have in common? Now the x, I'm left with 2x minus 3 equals 0. Okay? Can 2x minus 3 be factored any farther? Not a difference of squares?
Yes.
Yes? 2x minus 3 can factor it farther? What are you going to do?
Take out
Don't have anything in common. Well, that doesn't mean you factor. That doesn't mean you can factor that any farther. The only way to get 0 here, then, if you can't factor anymore, is either x, this has to be 0, or this part either has to be 0. So either x is 0, or the 2x minus 3 is 0. One of those two things has to be 0 before you can get 0 as the answer. That's one of the possibilities. And the other one, you solve for x over here. Add 3. You get 2x equals 3, divide by 2. X is 3 halves. Or x is 0. 3 halves? I don't see 3 halves. Oh man, the answer's not here. Oh yeah. 3 halves is 1.5. I tricked some people. Set it equals 0, get 2p squared minus 17p minus 9 equals 0. Factor out anything they have in common? Nothing. 2, 17, and 9 have nothing in common. They don't all even have the same variable. So I go straight into my t-chart, try to factor this. I'm going to have to do it by grouping because there's a t in front of my squared term. So 2 times negative 9 is 18, and then to add up to negative 17. Add to negative 17 or multiply negative 18. Well, I think I know what that would be. Negative 18 times 1 is negative 18 plus 1 equals negative 17. So that's what I'm going to break up the middle into. I'm going to say this is, okay, 2p squared minus, I'm going to call it negative p, or no, plus p minus 18p minus 9 equals 0. I put them in that order so that those two would have a p in common, those two would have a 9 in common. Makes it a little easier sometimes. So take the p outside, take the p outside, and you get 2p plus 1. Take a negative 9 out, you get 2p plus 1. I need them to both be 2p plus 1 equals 0. And you have 2p plus 1 as their common factor, and p minus 9 is what you took those away from. So, either 2p plus 1 is 0, or p minus 9 is 0. For this to be 0, you have to subtract 1. Get 2p is negative 1, divide by 2. Get p is negative 1/2, or p is, add 9, 9. Negative 1/2 and 9. I don't have a negative 1/2. Oh yeah, I do. Okay, what do you think we're going to do with number 16? What did we do to all the other problems ahead of this? Equal it to 0. That's the first thing we did on all the problems in the 4 previous. Kind of follow the pattern, you know, oh, we did it last time, maybe we should do it this time. We did it the 5 times before, maybe we should do it this time too.
X squared plus 9 minus 25.
What is it?
X squared plus 9 minus 25.
Okay, what's 9 minus 25?
16.
Now, what do I do?
Take out.
There's nothing to take out.
Yeah, there is nothing to take out.
So what do you do? It is a difference of perfect squares.
X and 4. Yeah, X and 4. X plus 4, X minus 4.
So if that's 0, then x either has to be negative 4 or positive. Rectangular room has an area of 136 square feet. The width of the room is something 9 feet less than the length. What are the dimensions? Rectangular room. Area is 136. The width of the room is 9 feet less. Okay, so the width, we got the width, we can call it x, and this will be x minus 9. 9 feet less than the length. Length is x. What are the dimensions of the room? How do you find the area of a square, rectangle? Okay, so x times x minus 9 should be equal to 136. What does x have to equal? So, let's distribute. X squared minus 9x. And what do you think we're going to do with the 136? Yeah. So now we have, oh, we're in luck. The squared term has a 1 in front of it. So when I do my t-chart, I don't have to go factoring by grouping. I'm looking for two things that multiply together to give me negative 136, and they add together to give me negative 9. What would that be? What goes into 136?
38 and 29? 38 and 29? Did you say 29?
No, multiply. What do they multiply together? So negative 18 and 17 is close. How about 8 and negative 17? That's going to give me the negative 9.
Yeah, but really nice. Why didn't you look at that? Wait.
So,
This is so much easier.
then my answer would be x plus 8, x minus 17. Which means x would have to be negative 8, or x would have to be positive 17. So, that's not the answer yet. What are the dimensions of the room? Can the dimension of the room be -8? Can the length be -8? No, not in this universe. So that means that x must be 17, and if that width, the length is 17, what's the width?
9 feet.
And that would be 8. So 8 times 17 does give me 136. Product of two consecutive integers. What does product mean, Michael? When you're going to product, what is that? On the product of two things. Is that addition, multiplication, subtraction, division? Multiplication. Two consecutive integers. So if you have two consecutive integers, and x is your first integer, then the next integer must be x plus 1, one bigger. And if you find the product of the two, you're going to be multiplying the two together, and you need to get 380. And yeah, you could probably use a calculator and just keep trying numbers. But we're trying to learn some algebra. So we get x squared plus x minus 380 equals 0. T-chart. I need two numbers that add together to give me -380, multiply together to give me -380, add together to give me 1. It looks like I'm going to be doing the same thing. What are two numbers that multiply together to give me 380? 10 goes into both of them. Let's start with 10. 10 and 38, because I'm not as smart as Ruben, I'm just going to go with the obvious one. 10 and 38, that's not close enough. So let's double 1 and cut the other one in half. 20 and 19. That works. But I need one of them to be negative. Make the -19. That'll give me a +1. So, x plus 20 and x minus 19 equals 0. Okay? So that means x is either -20 or x is +19. Is -20 a integer? Yes. Yes. So if x is -20, what's x plus 1? What's -20 plus 1? -19. So -19 and -20, or 19 and +20. +19 and +20. You have two ways to get 380. Both of them negative, both of them positive. So these, I don't have to solve for x. I just have to factor. It's kind of like the first number 3, 4, and 5, I think. Or 4, 5, and 6. Look for what they have in common. Is 25 and 64, do they have anything in common? No. No. So the next step is, let's try to see if they're a difference of squares. Since there's no x to the first term, or x squared, it's kind of looking weird. Let's see if this is a difference of perfect squares. Is that a perfect square? Is that a perfect square? So we'll factor. 25x to the 4th, what's the square root of 25x to the 4th? And 64? Positive, one's negative. Now, that one can't be factored. Can that one be factored? Not a difference of perfect squares. And there's nothing I can take out to make it that way. So I end up having to stop there. It is not prime. If there was anything past this, if there was any step past the original, it's not prime. Everybody got this one right, right? X plus 1, I'm sorry, x minus 1, x minus 1. Because if you do the T-chart, 1 times 1 is 1, and they need to add up to -2. So that's what you get. You don't have to solve, you don't have to do anything else except for that.
Negative one minus 1.
Negative 1 plus negative 1,
Oh, no, oh, yeah.
negative 1,
Wait, never mind, never mind, come on, get it. Get it.
just for the viewers at home.